this lesson, we shall be discussing the binomial expansions. This is Mr. Alfred Gordon. Binomial coefficients and factorials. Binomial coefficients. Now, a combination, which is n combination r, is equal to nr, which is equal to n factorial, all on n minus r in the bracket factorial, r factorial, where n factorial is equal to n multiplying n minus 1 multiplying n minus 2 and so on up to multiplying by 1. So, for example, for 5 factorial means 5 multiplying 4 multiplying 3 multiplying 2 and multiplying 1, which gives us a result of 120. Okay. Now also for 3 factorial means 3 multiplying 2 multiplying 1, which gives us a 6. Okay. Now, special values. For n combination 0 is equal to 1. Let's find out here. We're saying that n combination 0 will be equal to, from our combination formula, we know this is n factorial, so our n is still our n. Stay with me. And then we have n minus, now what's our I here? R is 0 factorial, and then we have r, which is 0 factorial. But remember that we said but 0 factorial is equal to 1. Okay, so the expression we have above will give us n factorial all on n minus 0, giving us n factorial, and then 0 factorial is 1. So n factorial on n factorial is equal to 1. Okay, so what we have here, n combination 0, what it means is that for any positive number, combination 0 is equal to 1. So if I have 5 combination 0, then it's 1. If I have 3 combination 0, then it's also what? 1. If I have 7 combination 0, then it's also what? 1. So we can conclude that any positive number combination 0 is 1. Also, for n combination n, okay, using our combination formula here, we know that n is n factorial, and then now our r is what? N. So we have n minus n in a bracket factorial, and then n factorial. Now this gives us n factorial all on n minus n will give us a 0 factorial and then n factorial. Now remember, we said 0 factorial is 1, meaning that we have n factorial all on n factorial, which gives us 1. Now this implies that a number combination itself, a positive number combination itself, is always 1. So 5 combination 5 is 1. Okay, we can also think of 7 combination 7 is also 1. So let's go this way. A positive integer, so a positive integer combination itself Now this follows that if you have n combination 1, still using the combination formula we have above here, then we have n is still n, so n factorial all on, all on n minus 1 factorial, and then we have 1 factorial. But this gives us, okay, you can write n factorial as n multiplying n minus 1 factorial all on n minus 1 factorial, and we know 1 factorial is what? Is 1. Now from what we have above here, now this is coming from the fact that if I have 5 factorial, 5 factorial gives us 5 multiplying 4, multiplying 3, multiplying 2, multiplying 1. But this, the whole of this expression here, okay, means a 4 factorial, because it is a 4 times a 3 times a 2 times a 1, which is a 4 factorial. So 5 factorial here can be written as 5 multiplying 4 factorial. And so if I have n factorial, then I can write n factorial as n, which is the 5, okay, and then 4n minus 1, okay, which is our 4 factorial. Okay, by simplification, n minus 1 factorial divides itself 1 time, and we are left with n. So a number for a positive integer combination 1 is always that positive integer. So it follows that if we have a 5 combination 1, then it's supposed to be 5. If we have a 4 combination 1, then it's a 4. If you have a 100 combination 1, then it's 100. Okay, now let's try the last one here together. Okay, so for n combination 2, so we have our combination to be n factorial all on n minus 2 factorial and a 2 factorial. But remember that n factorial can be written as n, also n minus 1 and n minus 2 factorial. Okay, all on n minus 2 factorial multiplying 2 factorial. But from our expression, n minus 2 and n minus 2, yes, divide themselves 1 time. Okay, leaving us with the expression n multiplying n minus 1 all on 2 factorial. I'll pause this video here and then continue the next lesson in our next video. Thank you for staying with me.